Awesome. All right. Thanks, folks, for joining. We'll go ahead and get started. Sarah will share the paper. All right. Before we get started on the paper, though, I just want to briefly go through RAG. Also the difference between because I notice like when I talk about search and retrieval methods and when I talk about RAG, sometimes I use them interchangeably, where search and retrieval is just the kind of traditional like ML version of RAG where it doesn't use an LLM. Like search and retrieval is going to be your traditional like recommendation system, search engines. But RAG and search and retrieval, they have the same use cases. Essentially, just RAG is going to have that augmented generation aspect. So RAG, retrieval augmented generation. If you didn't check out mine and Mikio's workshop, I think that was 1 week ago. Sarah, if you have the recording of that, I think folks that are attending this paper reading would be interested. But we showed how to use RAG like a full code along notebook for it and kind of went into the details of evaluations with it. But essentially, if you're using a retrieval augmented generation, you have this offline step where you have this knowledge base of articles, you're figuring out how to store and index them. You have a user query or any query that's available. You embed that query in the same embedding method that you're using to store all these documents. You then look up which queries are or which documents are the most similar to that query. You pool all those documents, you figure out which documents you want to give the LLM, you give the LLM, hey, this is the query, these are the relevant documents, can you generate a response for this user? And then you send that back to the user. And you might have been seeing RAG a lot. I'm sure that's why so many people are attending the paper reading, have attended our various RAG workshops and events, because we're seeing RAG being used most commonly in industry for an LLM use case. Like the most common use cases still in industry aren't large language model related. And Sally Ann and I will get into that, especially because Sally Ann's working directly with customers and seeing where their thoughts are around large language models and RAG systems. But what we're seeing more with RAG is the number of advanced capabilities, the number of complications that are coming up when implementing them in production, because I show you this workflow and it sounds pretty straightforward. It's like, okay, these are the steps, makes sense. But each one of these steps can have a ton of problems involved and require a ton of evaluations, like whichever indexing method and embedding model you're using to store this information, whatever lookup or similarity score or distant metric you're using to get these relevant documents, and then how you're ranking those relevant documents, the number of documents you're selecting, how you're scoring their relevance, all that factors in to what you're giving the LLM to generate that response. And then of course, there's all the response evaluations. So we want to answer like a lot of questions, like what people are thinking of with search and retrieval methods and leveraging RAG methods, because it can be as complicated as you'd want it to be, and you can add as many additional steps as you'd like. Really, with this paper, it talks about fine tuning and retrieval augmented generation, and we'll get into the paper because Sally Ann and I do have some thoughts. But in terms of fine-tuning versus RAG, from what Arise has talked about previously, is if you are using a search and retrieval system, you're using your own internal documents. If you're using a RAG system, you have to find a way to leverage your proprietary data when using normally like a third-party large language model. So if you don't have your own small large language model or your own open source large language model that you've trained, you're probably using a RAG system to give that LLM relevant information. This can be very helpful to increase performance for things like chatbots and for Q&A systems, but it is very costly. These are large systems, these are expensive, and there's more and more things coming out every day on like ways that RAG fails in production. So these are all being figured out currently. Like there's a lot going on that's trying to debug these systems, which is good because this is cutting edge, but there aren't a lot of teams that have implemented this and have it running smoothly in production. Fine tuning, we haven't seen coming up as much because like 6 months ago, people were saying like, oh, is there a way to fine tune these really large systems? And there weren't great ways of doing that, but now there are smaller systems to fine tune. And with that, Celian, I will get into looking at the piece. So, Sally-Ann, what were your first thoughts when you saw the title, like RAG versus fine-tuning, pipelines, trade-offs, and a case, it's cut off. Okay. And a case study on agriculture?
Yeah, when I first saw this title, I thought, the focus of the group at Microsoft was going to be on really comparing the performance of, a RAG system versus fine tuning on the same task. So I thought it was going to kind of answer that question that comes up a lot of like, which should I use? Should I use RAG? Should I use fine tuning? Because I think there's been a big discussion of like, okay, you should use RAG when you need in context learning, meaning like there's a task, like I think Q&A is the task for RAG, where you need to supplement the user's question with some context for the LLM to appropriately answer. And then, fine tuning has been said to be like only for formatting or style, things like that, or downstream tasks. So I thought we were going to maybe attack one task with these two approaches and then compare the performance. But that is not exactly what they did here. So my real takeaway from this, it's a very interesting approach that this group has taken. They are looking at the agricultural use case, which I think is definitely an interesting one. They list a bunch of reasons why they've chosen this use case, and I totally agree with that. So what they did was they took what they considered reliable sources from different agencies. A lot of them are like government agencies for this agricultural information. They extracted all of that information from the PDFs and they used that to create like QA pairs. They then used that for RAG and fine tuning. So that's like a high level of what is going on there. I guess any questions on that, Amber? Any follow-ups?
Yeah, and folks, feel free to use the chat and Q&A if you have additional questions. Yes, so Stallion, can you tell us about the way in which the extraction from, because we've talked about have structured data extraction previously, using LLMs for structured data extraction. Like, did they do that? Did they do that in a different way?
Yeah, what's really interesting is they didn't choose to use LLMs to do the structure extraction from the PDF. So what everybody may or may not know here is PDFs aren't like your usual text documents. They have like a weird structure to them. So extracting information can be difficult because you have to not only get the actual text information, but you need to kind of keep that like the structure of the PDF intact. So they talk a lot about needing to do that, which is absolutely right. But they went with some more traditional methods like PDF to text. That's, I feel like, one of those old school open source Python packages that you can use for like OCR tasks. They mentioned another one, which I'm not super familiar with, which is generation of bibliographic data, which is, I guess, another
Oh
one
yeah, that's like
for
old
scientific
one.
literature. So that one was and interesting. So my first thought of reading that was it was interesting that they chose to use the traditional methods. I would have loved maybe even seeing how an LLM did that. I almost would have loved to see like a fine tune, like focus on the fine tuning a little bit more and see how well they could extract information from these like kind of old scientific PDFs. So that's how they did it. So yeah.
Okay. And so this is the general workflow that they did. So
Mhm.
you mentioned like how they created and generated the QA pairs. Um, so real world use case, but not real world data, the generated data and information from these large language models. And then they broke it up into two areas of fine tuning and RAG, and then connecting that to GPT-4, and then having GPT-4 based evals. Can you dive into like this process here? And
Mhm.
because it's interesting the like what they chose to do first, and like the kind of process of this.
Yeah, so what's interesting is I think I know it's a visual, right? That's supposed to simplify things a little bit, but there are some kind of intermediate steps of where like for the QA generation, so the first step is they do the question generation. And so they're kind of feeding in those JSON files from the extracted text. So I think if you scroll down a little bit, maybe a page or two, they show you kind of what the final output of extracting all the data from the JSON is. A little bit more. This is what it looks like if they don't include the
Yeah.
structure.
Right.
Um,
And the raw
there
text.
it is right there. Okay, so they're using this kind of JSON that they've created from those PDFs. So this is keeping in not only the information, but all the structural information as well as any like related. So you can think of if you're reading a PDF and maybe it's talking about something and then it references an image, like those relationships are all kept in this JSON. And so they feed this to the LLM and they ask it a series of kind of questions. So like, you know, they basically prompt it to create questions for them. But then they use RAG to generate the answers, which is kind of left out of that initial visual that we were looking at in that pipeline. Um,
Yeah.
so to create the question answer pairs, they first create questions and then they create the answers with the RAG pipeline.
Yeah. For like
Make sense?
this is
Yeah.
the
Yeah, so this is like identifying the supporting context that's used during question generation. So this isn't even really exactly what they use to generate the questions, but this is kind of how they verified the supporting context there.
yeah. Okay, cool. And then yeah, this is their answer generation portion
Exactly.
here.
So they prompted, they say, you're an expert in agriculture. You need to format questions from documents to, assess the students. They're like making a test almost. And then like they give them the metadata from the documents. And then they, ask it to, give a answer.
Hmm. Yeah, and all this is with GPT-4.
Yep.
Okay, and then we have the fine fine tuning aspect here.
Yeah, so
And
they're taking those questions and answers, those that data set that they've created and they're fine-tuning. They fine-tune some llama models. So I believe it's Open Llama 3B, 7B and 13B. And then they did that with some fully sharded data parallelism. Um, and what's interesting is they did GPT-4 a little bit different. So because it's larger and expensive, something that, everybody probably is familiar with these models, they had to take a different approach. They actually did LoRa. I would have liked to see them be a little bit more consistent with their approaches. I feel like, when we're trying to kind of get this comparison of how models are doing with fine tuning, a set of models one way and then, another one another way. I feel like that just adds a little bit of an extra variable there. So it's a little bit hard to like feel confident in how to interpret these results too. So that's something that
yeah,
I noticed while reading these.
and we did do a paper reading on the Laura paper as well if folks are interested in seeing how that method is used. Okay, so that, and let me just go back to, yeah, because um,
Mhm.
this is like the kind of agricultural textbook that you would open up to get, and then those levels of extraction to get to the QA pairs here. So we've kind of gone through these parts, and
Yep.
then in terms of these next steps for evaluations, Sally Ann, like we cover, I guess like yeah, our company does specialize in doing
Yep.
evaluations and productions. So were there some obvious things that you were like expecting to see? Like what did you end up seeing? Did you have kind of feedback for like what would make a good next step for this paper for evals?
Yeah, what was really interesting to me is I feel like they went outside what I would consider maybe like the norm for evals. I feel like there's a lot of opinions surfacing, of course, arise. We have our own. But there's like a lot of, I think, groundwork being done for evals. And what I was really surprised, especially for a group coming out of Microsoft, was there were kind of new evals that I haven't really heard of. So I think relevance is an eval we hear of a lot, especially with RAG, right? Because there's always that argument of, how RAG works is to fetch context based on a similarity metric, which is going to look at like, the embedding similarity, but that doesn't always mean that the context retrieved is going to be the most relevant. So that one was expected. Actually, if you scroll, there's two places. If you scroll up to
Yeah.
actually 15, so for
Oh,
everybody
okay.
that you're reading this paper, they do evaluate their questions and answers with different criteria, and also the QA pairs. So this right here is the QA pairs. And so they measure the relevance, they say, to the chat GPT, not chat GPT, GPT-4. They're basically prompting it, say like, hey, rate this question on a scale of 1 to 5. Is it a question that would be asked by a farmer or not a farmer? So the relevance that I was expecting was not actually the relevance that they ended up using. This is actually a relevance to the I guess use case. So because this is like an agricultural use case, they were asking if the question was actually relevant to like agriculture, which I thought was interesting. Like I expected this to be more of like the traditional relevance. And then they, followed that up with like making sure the question was relevant, like without considering any context that was given. So it's just a really interesting way to think about it. I do think if you're going to build an application that's super specific to like an industry like they are here, I guess it is worth measuring, like is this something relevant to my use case or not, but just was just different kind of eval than I'm used to. The other thing that I
Especially
thought
with
was,
so much research being done on
yeah,
relevance and relevant scoring, and even the out of the box metrics that are available that support relevance. Like when you have to like redefine relevance, so people understand what you are meaning by relevance. It's a little different for that. Someone did ask how they were converting PDFs to JSON. What's it?
yeah,
What
I believe
using
so. They
ML?
use some like traditional ML techniques there. So they used I believe they ended up with this. I'm gonna just type it in the chat. It's GROBID. This is generation of bibliographic data. So it's a library that specifically is tailored for extracting data from like scientific literature. They did talk about like PDF to text, like some of those other traditional ones, but they didn't end up going with that. So I can throw it in the chat there.
Yeah,
That was something I had not heard of.
yeah.
Um,
But yeah, all I knew is they didn't use LLMs for structured data extraction.
Very surprised by that.
Great question.
Yeah, great one. Okay, so we were
Okay.
talking about the evals. So what's interesting kind of to your point is like, like relevance to some people might be something different. They use converge as what I think you and I might think of as relevant, which is like, can the answer be extracted from the context from RAG?
Yeah.
And I think that's kind of, so convergence to them is maybe relevance and like are evals even, or what a lot of the industry um standard is. The other thing that I thought was kind of interesting, or there are two that were actually really interesting to me. So overlap was an eval that I thought was super interesting, and I recognize that metrics, KL divergence. That's one that we support. It's a drift metric because that's how I usually think about it. And so what they did here was kind of to compare the overlap of like between the questions and like the context, which I thought was an interesting application of KL divergence. I feel like there are other metrics that we saw very early on with like generative AI, especially with the like summary of like a blue score or a rogue score, like those metrics that kind of see how similar the two texts are.
Mhm.
I thought it was a really interesting application of that metric. The other one was details. So the way that they assess the level of detail was actually to count the number of tokens. which I thought was interesting because, like, I don't know, you and I have seen a number of times an LLM has generated this incredibly lengthy response, and it's kind of just regurgitating the same information over and over again. So it's interesting to me that they just use like the count of tokens to determine how detailed something was, because I think that could be potentially misleading.
Yeah. Because yeah, these I have no idea how these metrics were selected. They're I guess like going down to 17, page 17 here, coherence, relevance, groundedness are what we are hearing a bit more commonly when we're talking about RAG systems, but not even like a precision, in not even like a precision was used. They used a lot of a scale of 1 through 5. And things I don't like about 1 through 5 scales is I don't know how this was normalized. I don't know the distribution. Um, and then, you have KL divergence, which could be from 0 to 1. But from my understanding, the overlap will be 0. And it's a good thing if the question just restates, or the answer restates the question
Mhm.
almost in this case. Um, so that's interesting. If people are using RAG systems, I'm curious for what metrics you're most commonly using. Uh, just like as a kind of brief part in like for a rise, we tend to evaluate like responses with hallucinations and correctness, but for anything involved in RAG, especially when those documents are being returned, we still use traditional search and retrieval metrics. So precision, NDCG, like traditional ranking metrics. And I think commonly, where did that paper go? Commonly, instead of using like a scale like 1 through 5, just is this relevant or is this not relevant? But yeah, I'm not sure how to compare it with because essentially, right, Sally, and they're just using GPT-4 to give the feedback for that relevance and providing it a prompt for that ranking.
Yeah, exactly. And so I totally agree. I do like the binary just because it honestly, for me, it's operating in a world that I'm more like I'm comfortable with. Like I've used those metrics for years. I understand how to interpret them. But when we're talking in this new world of like, what is there, 8 different new metrics essentially here that
Yeah.
they're looking at. And to your point too, like how do I interpret those? How do you feel confident in them? It's just a little bit, I feel like there's just more room for error when you're giving them a scale to evaluate something on, and by them I
Yeah.
guess LM.
Yeah. And for the point you mentioned about details being counting the number of words and how it almost contradicts like what we think when we think of high token counts, like for the current research, like in LLMs, higher token count means higher latency, slower performing models, and then additional paper readings we've done about loss in the middle, like the loss of contextual information, the more words that you have. So, like more words not being directly related to relevance, and sometimes it being inversely related to how relevant something is, if it's just a very long-winded answer.
Yeah, totally agree. That one definitely caught me by surprise. So it's interesting to see. So, kind of going through the rest. So they do some answer evaluations, kind of they have their own set. They look at coherence, relevance, groundedness. And then they do evaluate kind of the model with like looking at, those evaluation with a guideline. So they kind of they prompt using kind of guidelines. And they also did some experiments too to see like the difference between different quality of QA pairs by like GPT-3, 3.54, using different context setups, which I thought was interesting of, having the, I believe they did like partial context and like, no, I think it was no context, and then like external context. So it was interesting to see them do all of those variations, but again, kind of going back to where we started in our conversation, it wasn't the experiments I expected to see. So I feel like there was kind of a lot of separate experiments going on, kind of covered in one paper. And so there was a lot to kind of go through. And in the end, they didn't really give me any new information that I feel like I didn't already know. At the end, their conclusion essentially said, like, look, RAG improves accuracy. It's effective for tasks where data is like contextually relevant. And there's that kind of low initial embedding cost. But really, this is going to be for like in context info. And then, for fine tuning, they say, it's precise output, which is like that going back to what I said in the beginning about like fine tuning being for like the style of an LLM's output. And it's effective for specific tasks, but it does have a high cost. So all the stuff at the end, like it wasn't, I don't feel like really anything new. It was kind of a reiteration of what we already kind of know about these tasks. But that's kind of my take on the paper.
Yeah, and I thought it was interesting because they're using some different prompts, but they're not experimenting with the prompt engineering aspect
Mhm.
to see,
Yeah.
especially when we've seen how much that really improves the performance of your RAG and of your if you have a fine-tuned model for that capability.
I think really, and I'd be curious what your thoughts on this. After reading this paper, I feel like it was very focused on perhaps like a synthetic data generation use case. Like I feel like this was less, I think my first initial thought was like, oh, we're gonna make like a useful like copilot or something for people who are in agriculture, farmers who are in a specific region and they have a question that might not be as like easily found. Like they might have to search through textbooks and textbooks to find it, something like that. And for me, what it really feels like is they're experimenting with, RAG and fine tuning for generating these question answer pairs. So I thought that was kind of interesting. I think we're seeing synthetic data generation come up more and more, but I would have liked it maybe to focus a little bit more on like the quality of the data set.
Mhm.
Like there's another paper out of Microsoft that, we covered like 2 weeks ago, about like, textbooks are all you need. The kind of concept of using super high quality data for fine tuning is super important. I would have loved to see them maybe dive into that. They talk about how they use specific data from agencies from different countries and like why they chose them, but I would have loved them to kind of drill into that a little bit more and like actually see if those agencies actually gave high quality information.
Yeah, I think I've seen like more more of what I'm seeing now are ways of trying to leverage agents, trying to use smaller models, um,
Mm-hmm.
trying to essentially like troubleshoot RAG on the different pain points. Like this towards data science piece came out recently and just actually implementing it in production and seeing like what's going wrong in production than just kind of traditional research of like, oh, would fine tuning kind of be better than search and retrieval techniques. It is very interesting seeing how different a RAG piece from Microsoft, like because they have so many research teams
Mm-hmm.
covering it and like the different approaches that are being taken. I feel like the team that wrote this paper is maybe more of a machine learning team
Mm-hmm.
that wanted to dive in and take a take a different view on how to evaluate these models as
Yeah.
opposed to like what we've been seeing for fine tuning and RAG. I don't think I've seen a fine tuning and RAG comparison where they don't talk about the prompt engineering aspects and they don't talk about the quality of the research. I also didn't like to your point about like the conclusion. I didn't really get a conclusion to the agricultural use case, like
Yeah.
which they put in here. Like if I was someone in agricultural studies trying to see how to apply large language models or RAG in my work, like I don't think this would have been the right paper for me if I was an like AI in agriculture.
Yeah, it kind of just said the basic thing that we saw all the time that just like it's promising. So we don't really get anything conclusive about that. I mean, it does seem like the premise works, right? Like you can use RAG, you can use fine tuning to create these high quality or somewhat high quality QA pairs. But yeah, it really wasn't that conclusive on that specific use case. Just said there's, promising results there. And kind of to your point of like it being different groups, I am actually surprised that they didn't, at all borrow from those other Microsoft groups of what they're working on. Like the fact that they didn't even like include like Phi 2 or Phi 1.5 and this as the model evaluations. Like I was kind of sad to see that they only use the like true large language models because from what I'm seeing, these small language models seem like they can pack a punch and just need so much less data. So it would have been, I think, even cooler for them to maybe look into how like RAG works with those smaller models and like fine tuning with smaller data sets. I just think there's like a step further they could have taken, and they focused a lot about on the data here, even though that wasn't the whole premise.
Yeah. And I'm kind of surprised, with evaluation metrics that Microsoft is putting out, like this wasn't their kind of standard for what they were using for evaluations for Microsoft. But yeah, it's interesting. Like maybe we can get in contact with the authors and ask some questions related to it. I also think, whenever there's big topics coming out, and RAG has just been such a large topic over the past few months, and what we were talking about kind of right when this discussion happened was how customers and how teams are saying they want to use large language models. They don't know how, they don't know where it would fit. And RAG is a good use case for them because they just have to provide a certain amount of information, a certain amount of data, and then they can use these systems. So I think part of it is a bit of the hype that's just around RAG systems. And maybe now for like the last bit of time, we can have a discussion on like the future of RAG, of
Mhm.
these systems, like how things are starting to evolve, because it's almost like overwhelming, the amount of RAG that's coming out and
Yeah.
all the RAG we're seeing.
It is crazy. I feel like it was at first, I feel like LLMs came out, right? And like everybody wasn't really like they're just so caught up on the tech and then it could do all these new things. And it kind of came to the point where like, okay, we need to be able to adjust these LLMs in some way. And I feel like RAG just took over. Nobody cared about fine tuning. And I feel like fine tuning is slowly creeping up again to become maybe the dominant choice for these tasks. So it's really interesting to see my personal take on it with all this research that's going on to these small language models, the kind of bringing back the whole garbage in, garbage out concept of like using only high quality data sets. I think fine tuning could really be the future. Because I think you mentioned it earlier too, of like RAG's really only for those Q&A use cases. For a majority of the LLM tasks, it's not going to work in the way that people might expect it to.
Yeah. Because when we think of, oh, you want to implement a RAG system, like the first thing you're going to need is not having your own language model for your various tasks. You're going to need whichever large language model you're going to want to use. You're going to need the budget around that because RAG is for performance optimization, not if you have like budget and computational constraints,
Yeah.
really. And
I
so
think
it has to fit that use case, has to fit that budget, has to kind of fit a lot of these aspects.
Yeah, you brought up an interesting point there is, and they mentioned in the paper that it's like a low cost, like initial cost of embeddings, but like the long-term cost of RAG is not small. I think that's something that's kind of deceiving a lot of the times when RAG is being discussed. Like it, I think it's like the cost effective, like fine tuning so expensive, but like again, kind of going back to those small language models and like the efficient ways to fine tune that we're seeing, like the LoRa, the Glora, the quantization. Like I feel like there's a million ways that you can do efficient fine tuning these days. So I think it's just deceiving to say that RAG is the cheaper option.
And when I go to conferences and I ask people like, what is their large language use case. It's still a lot of internal language use cases of doing
Yeah.
structured data extraction and doing like uh anything where like OCR is
Mhm.
involved, doing entity recognition. So the use cases haven't really changed for what people need language models to do. And a lot of them have just been building up, building up BERT and building up some of their other methods, like traditional machine learning methods that they've used. I think we'll see more potential use cases for LLMs and maybe less on RAG. I mean,
Yeah.
you were talking about seeing these kind of smaller models, and we're seeing better development around these open source language models. Um, you only need RAG because you don't have access to these models and you can't train them yourself, but that could change moving forward, and then you wouldn't need a RAG-based system. And then the other part that I think is really interesting is the storage of this data, because we talk
Mhm.
about there is an expense with RAG that a lot of people don't focus on because they focus on the performance aspect. But the storage and computation of embeddings, where all these models are tabular and they've been tabular for a long time, like that's a huge undertaking. A lot of teams are starting to do that. They are starting to incorporate vector databases, but you work with a lot of customers, Sally Ann, like, does it feel like overwhelming for them? Like thinking of like, they want the results, but like everything that's required in terms of infrastructure that's needed to get there.
Yeah, it's interesting. I think it is, there's a lot more to it than I think teams initially think when they're starting on RAG. But I think another thing that's worth noting is a lot of the use cases you do see are those like traditional, like natural language processing tasks that like they're traditionally done with like our smaller foundation models like BERT, and like now they're kind of transitioning them over to these larger language models. Um, so I think that that's worth noticing and then noting, and then yeah, there's a lot of infrastructure that's required, and then you got to choose, right? Like, okay, which database are you gonna go with? And like there's a lot that just goes into setting up a RAG system. It's not magic. There's a lot of tweaking and getting it just right to even perform in the way that you want it to. So that I think is kind of the downfall of RAG too.
Yeah. And then we got a question from Johnny from our community. Does fine tuning involve more initial upfront costs compared to RAG?
I think a lot of things depend on a lot of things. I
Yeah.
know, so, like, what model are you fine tuning? How much data? Like, what are the resources you're going to use? I think there's a lot. I would say if you really want a very simple answer, yes, it's going to be a little bit more expensive upfront, but it doesn't have to be. That's what I would like
Yeah.
to call out.
And that's why we typically say, once you have a pipeline, if you are using a large language model to experiment with prompt templates, like we have a prompt
Mhm.
playground in Arise, where just experimenting with the wording and the messaging you're giving your large language model, like your large language model is an assistant.
Yeah.
So if you are actually returning relevant content and your content metrics look good, and if you have any questions on like how to tell the difference, how to evaluate it, like that's the question Sally and I answer all day long. So we're happy to answer those questions in community. But essentially, if you're getting bad responses, but you're actually getting decent retrievals, like the documents are there, you're supplying decent documents, then just playing around with the prompt template and doing prompt engineering is going to be the most cost-effective solution. Yeah, we tend to say fine tuning is very expensive. And, going back to RAG, it does depend if you have that data ready. You already have that data ready, because obviously a huge cost is going to be around creating that data and making that data available. If you have to annotate that data.
Mhm.
Um, so there's a lot, and then you have LLMs evaluating LLMs and so on and so forth for a lot of costs around that. But I haven't really seen a paper come out on most efficient, like cost-effective solutions for like what's the cheapest way to do it, only the
Mhm.
kind of the best performing based on leaderboards and everything.
Yeah, I think we're starting to like, I don't think anybody's ever like been like, this is the way you should do it for cost effective. But I think it's always, when you read the papers, if they are talking about fine tuning, they will always like highlight the fact that this will
Yeah.
save you some money, which is, it's good to see. And it's helpful. But yeah, definitely make sure that you actually need to fine tune, which I think is what you're talking about there, Amber.
Awesome. Well, thanks everyone for attending. I think that was the rest of the community questions. Again, if you have any questions on RAG, fine-tuning, prompt engineering, evaluations, we are in the Arise community Slack, and Sarah just sent out the link to that. So if you haven't already joined, please join, and this recording will also be available. Thanks, everyone.
Thanks, everyone.